Here we have a SAT math problem. Okay, let's go to the question. The function f is defined by f of x equals to ax square positive bx positive c, where a, b, and c are constants. The graph of y equals to f of x in the xy plane passes through the point 7, 0 and negative 3, 0. If a is an integer greater than 1, which of the following could be the value of a positive b? Okay, let me take the given function as it is. That is f of x equals to ax square positive bx positive c. Actually, it is a quadratic function. Its graph will be a vertical parabola. Since the leading coefficient a is an integer greater than 1, that is a positive value, so we'll be getting a vertical parabola for this function which opens up. Okay, now let me consider the 2 points we have over here through which the graph of the given function passes. Okay, in these 2 points, the y-coordinate is 0. Since the y-coordinate is 0 in the given 2 points, we have to consider these 2 points as x-intercepts. That is 7, 0 is the first x-intercept of the parabola, and negative 3, 0 is the second x-intercept of the parabola. Okay, here in this one, the x-coordinate is 7. Here, the x-coordinate is negative 3. From the given two x-intercepts, I will be able to get the two factors of the quadratic expression we have over here. Okay, now to get the two factors, what I have done is in these two equations, I have to make the right side 0. Okay, now let's consider the first equation. To make the right side 0, I have to subtract 7 from both sides. When I do so, the 7 negative 7 will cancel out. I am getting x negative 7 equals to 0. Now to make the right side 0 in this equation, I have to add 3 to both sides. When I do so, negative 3 positive 3 will cancel out. I am getting x positive 3 equals to 0. Okay, this x negative 7 and this x positive 3 are the two factors of this quadratic expression. Okay, now let me write the given function in factor form. Since the leading coefficient over here is a, the a should be written as it is. And now let's write the first factor, that is x negative 7, and the second factor x positive 3. Okay, now I have written the given function in factor form over here. Okay, f of x equals to a times, let me multiply these two binomials using the FOIL method. Okay, first let me multiply the first terms, x times x is x square. Then we have to multiply the outer terms, x times positive 3 is positive 3x. Now let me multiply the inner terms, and negative 7 times x is negative 7x. Let me multiply the last terms, negative 7 times positive 3 is negative 21. Then we get f of x equals to a times x square. Now when I combine positive 3x and negative 7x, I am getting negative 4x negative 21. Okay, then we get f of x equals to, we can distribute this a to this x square, negative 4x and negative 21. Then I am getting ax square. When I multiply this a and negative 4x, I am getting negative 4ax. And when I multiply this a and negative 21, I am getting negative 21a. Okay, now I got the given function in this format over here. Okay, now let's compare the original function and the function what we got over here. So when I compare this one and this one, the place of a, what do we have? So actually a is a coefficient of x square. Here also the same a we have as a coefficient of x square. So we get a equals to a. At the place of b, that is a coefficient of x, we have negative 4a, that is a coefficient of x. So we get b equals to negative 4a. Okay, so here we don't need to compare the constant c and negative 21a, because our aim is to get the value of a positive b. Okay, now let me try to get the value of the expression a positive b. So here we can take this a as it is, and for b we can plug in negative 4a. So then we get a negative 4a, then we get a positive b equals to a negative 4a is a negative 3a. And also the question says a is an integer greater than 1. So a is an integer greater than 1. When a is an integer greater than 1, so the possible values for a are 2, 3, 4, 5, 6, 7. So these are all the integers greater than 1. So these are the possible values we have for a. Okay, now let me consider the first value 2 for a. Then we can plug in this 2 for a over here. In that case, I am getting negative 3 times 2. That is, I am getting negative 6 as a value for a positive b. If I consider the second value of a 3, when I plug in this 3 for a over here, negative 3 times 3 will be negative 9. When I consider the third value of a 4 and I plug in 4 for a over here, negative 3 times 4 will be negative 12. When I consider the fourth value of a 5 and when I plug in 5 for a over here, negative 3 times of is negative 15. In this way, I can get multiple values for a positive b. Okay, so when I consider the values we have for a positive b in the given answer choices, we find this negative 6 in answer choice A. So among the given answer choices, so the value negative 6 in answer choice A could be the value of this expression a positive b. So the correct answer choice for this question is a, -6.